Uranus is the seventh planet from the Sun in our solar system, known for its unique features. It's a gas giant with a pale blue-green appearance due to methane in its atmosphere. Discovered in 1781 by William Herschel, Uranus is the third largest planet. It has a rotational axis tilted at about 98 degrees, causing extreme seasons and making it appear to roll on its side as it orbits the Sun. The planet has a set of thin rings and 27 known moons, the largest being Titania and Oberon. Despite its distant location, Uranus has been studied by telescopes and spacecraft like Voyager 2, providing valuable insights into its composition and characteristics.
Uranus plays a significant role in our solar system, contributing to its overall dynamics and providing valuable insights into planetary formation. Some key aspects of Uranus' importance include 1. Understanding planetary formation. Studying Uranus helps scientists comprehend the processes involved in the formation of planets. Its unique tilt and composition offer clues about the conditions prevalent in the early solar system. 2. Magnetic field and interior structure. Uranus has a peculiar magnetic field that is tilted relative to its rotation axis. Investigating this anomaly contributes to our understanding of planetary magnetic fields and the internal dynamics of gas giants. 3. Seasonal variations. Uranus experiences extreme seasonal variations due to its tilted axis. This provides scientists with a unique opportunity to explore the effects of axial tilts on climate and atmospheric dynamics in the outer regions of the solar system. 4. Rings and moons. The study of Uranus rings and moons offers insights into the broader processes of satellite formation and the dynamics of ring systems. Titania, Oberon, and other moons provide valuable data for comparative studies with other planetary satellites. 5. Atmospheric composition. Uranus' atmosphere is primarily composed of hydrogen, helium, and methane. Studying its chemical makeup helps scientists better understand the evolution of atmospheres in the outer solar system and the role of volatile compounds in planetary atmospheres. 6. Voyager 2 mission. The Voyager 2 spacecraft provided detailed information about Uranus during its flyby in 1986. Data from this mission significantly expanded our knowledge of the planet's structure, atmosphere, and magnetic field. 7. Outer solar system dynamics. Uranus, located beyond the gas giants Jupiter and Saturn, influences the gravitational dynamics of the outer solar system. Its presence plays a role in the stability and orbits of other distant objects like trans-Neptunian objects TNOS and the Kuiper Belt. 8. Comparative planetary science. Comparing Uranus to other gas giants, such as Jupiter and Saturn, enhances our understanding of the diversity among giant planets. Each planet's unique characteristics contribute to a more comprehensive picture of planetary evolution. In summary, Uranus serves as a crucial celestial body for planetary scientists, offering insights into the broader processes that govern the formation and evolution of planets within our solar system and beyond. A collision between Uranus and Earth would have catastrophic consequences for both planets. However, such an event is highly unlikely and practically impossible due to the vast distances and dynamics of our solar system. 1. Massive destruction. If, hypothetically, Uranus were to collide with Earth, the impact would result in massive destruction for both planets. The energy released in such a collision would be on an astronomical scale, causing widespread devastation. 2. Formation of debris. The collision would lead to the fragmentation of both planets, creating a significant amount of debris. This debris would likely form a massive ring system around the combined remnants. 3. Alteration of orbits. The gravitational forces unleashed by such a collision would have far-reaching effects on the orbits of other celestial bodies in the solar system. The balance of gravitational interactions among neighboring planets and other objects would be disrupted. 4. Impact on moons. Uranus has a system of moons, and the collision would likely affect them as well. Moons could be ejected from their orbits or captured by the remnants of the merged planets. 5. Potential for new celestial bodies. In the aftermath, the remnants of the collision might coalesce to form new celestial bodies or contribute to the formation of a new planetary system. It's crucial to emphasize that this scenario is purely hypothetical and does not align with the current understanding of the stability of our solar system. The distances between planets are vast, and their orbits are carefully balanced due to the dynamics of gravitational forces. The likelihood of a direct collision between Earth and Uranus, or any other two planets, is extremely low. If you like this video, please subscribe this channel and press bell icon for more informative videos.